Alright, so there's actually one more video in this section. I was going to include this in the soluble versus insoluble video, and I just spaced, like, in my title there I had a plus and I missed it. But there are different properties for dissolving a gas versus a solid, and it's probably good to actually have this as a standalone video because not everyone is super comfortable with this idea of dissolving a gas. Even though it's incredibly important, none of us would be here today without it. But you don't really see it in action. So solids, yeah, you see that. You know, if you've ever cooked or anything like that, or made Kool-Aid or whatever, instant coffee, you've seen solids dissolve in liquids. So it's not too crazy, but we don't tend to see gases doing that, not with our bare eyes. So there's different rules depending on what we're talking about with a solid or a gas. But what it boils down to is, so first we got to worry about which one we're talking about, whether it's a solid or a gas. And we're going to mess with temperature, and we're going to mess with pressure. Okay, so if I heat up my solution, I put it on a pan and I heat up the solvent, whatever it is, water or whatever, what's going to happen? Well, for gases, a hot solution has less solubility. Okay, so this is why whenever you see work being done on watersheds, creeks, rivers, whatever, like the Amazon Canal out here in West Eugene, one thing they really work to do is lower the water temperature, because that's going to increase solubility of gases like oxygen, and so things like fish and other aquatic vertebrae can more easily survive. So if the water gets too hot, aquatic life can actually asphyxiate. It can suffocate to death because they're not breathing atmospheric oxygen, they're breathing dissolved oxygen in the water. That's what fish do. So they pass it, it goes through their mouth and out the lung, or out the gills, and it passes over lungs as it does that. Very different from how we do things, where we just take in air, we release air. So we get it straight from the source, whereas they have to get it through a water medium. Now, if you increase temperature of a solution that has dissolved solids, this is actually going to be more solubility. It's going to increase. So there's going to be more solubility. So you can get more stuff to dissolve. So if you've ever made like simple syrup, if you put too much sugar in it, you let it cool back down, you start getting like sugar crystals. Or if you've ever just done the experiment where you make sugar or salt crystals, generally you get the water up real hot, you dissolve in your salt or your sugar, and you cool it down and you start seeing this crystal formation. And that's because the solubility increased to dissolve it, and then as it cools, it can hold less and less in the liquid, and so it starts collapsing out as a solid, or we say crashing out of the solution as a solid. Now, if we increase pressure on gases, we can essentially push them into the liquid and be dissolved in the liquid. So this is going to cause more solubility. Oops. More solubility. Totally didn't misspell that at all. Alright. If we do this with solids, it doesn't matter. You can't compress the solid, so yeah, there's no change. So we've got these two sets of rules. And if dissolving gases seems weird, I always use something like a carbonated beverage as an example, and so I'm totally going to get $1 million from Pepsi for this, but there's a couple things we do to keep our Pepsi from going flat. If you're a Coke drinker, well, the good news is we do offer bio bonds again in the fall, and you can have your choice of any number of instructors, not just me. So, maybe one of them drinks Coke. But what we do is we put a lid on it, and we also keep it cold. And guess what we're doing? We're keeping the temperature down, so we have more gas solubility. We're keeping the pressure up by putting the lid on it, because if you take the cap off, you get that sound. I don't know if you heard it. I tried to open it right by my mic. You probably just heard me hitting my mic with a bottle, but whatever. Just another day at the office. But you keep the lid on, it keeps the pressure up, because as the gas undissolves, it pressurizes the container and starts forcing it back into solution. So you get an increase in pressure. That's going to increase the solubility. So we're keeping it cold, and we're keeping it pressurized to keep our carbon dioxide. So the bubbles in soda are carbon dioxide. And same with like beer. There are some nitro beers that use nitrogen bubbles, but it's the same principle. It's still a dissolved gas. So it's just a different gas. Whereas with solids, you heat it up, you can get more to dissolve, and playing around with pressure really just has no effect. Which, by the way, I must say, for those of you that do drink Coke, you know, the last round of people protesting and police violence and all that, this solved it all right here. It was I don't know what Kylie Jenner's up to, but she needs to get out of retirement and start handing out Cokes to those police officers, because, you know, there'd be a few less people getting, you know, tear gassed and rubber bulleted and all that, and that's just all it takes. That's what I remember. I don't know what year it was, 2016-ish maybe? No, it couldn't have been. It was before that. 2015, something like that. 14. I don't know where she is. Yeah, you give somebody $1 billion, they just stop working. Who knew? All right. So yeah, this was kind of the last thing, and so you know, same deal with waterways. We rely on dissolved gases, so we do inhale gases, but we do have to dissolve them into our bloodstream. Now we cheat a bit. It's not like the O2 just dissolves. We have, you know, heme groups in our blood with hemoglobin and red blood cells and all that really do the heavy lifting and transport it around. But we do have to do a gas exchange. We got to go CO2 out, O2 in. We're doing that every time we breathe. Whereas solids, I mean, we got to get those to dissolve a little bit too, like when we eat food. But just let it sit in our stomach for a bit, and it happens. Or it doesn't, and then it still takes care of itself somehow. All right. So yeah, this was just a little thing I forgot to mention earlier. So it's not really a full video, but be aware you've got these different rules. So if you want to get a gas to dissolve more, cool it down, pressurize it. If you want to get a solid to dissolve more, just heat that solution up, and more of it will dissolve. You want less solid to dissolve, cool it down. Just do the opposite. Same with gases. You want to get gases out of solution, you heat it up, you depressurize it. And so generally when water starts to boil, what you're seeing water vapor escape, but you're also seeing all the other gases go with it, because it's less soluble because you've increased the temperature. So one thing you can do if you ever want like clear ice cubes is you take water, you boil it, and then you pour it in the ice tray and you freeze it, and you won't get all those little bubbles, which are actually gases undissolving from the ice as it freezes. So you get that nice clear solid ice. That's the secret to that, if you didn't know already. And it actually has to do with the solubility here, because as the solvent turns solid, it's no longer able to dissolve anything, because it has to be a liquid to be a solvent. So you're losing your solvent to the freezing process, which is just a fun little side adventure there. Alright, so yeah, this one I actually filmed it at the very end because I realized I forgot it, but it will be inserted. It'll be like the, I think, third video. So I said 3 over and over again. 4 is the new 3. Enjoy.